In this video, we're going to do an example of integration by substitution. So let's say we are given a function f at x is equal to x times 1 plus x or 1 plus 2x squared to the power of 7, and then we are told to find f at x dx on the interval from 0 to 1 over root 2. How do we find this integral? How do we find this definite integral using integration by substitution? Well, the first thing we're going to do is we're going to define our placeholder here. So we're going to let t equal this, whatever is inside this bracket here. So t is going to be 1 plus 2x squared. And so the derivative of that, dt by dx, the derivative of t with respect to x, is going to be equal to 4x. Using our power rule, this reduces to 0, this 2 multiplies by that 2, and then the exponent reduces to 1. So there we have it. That's our first step. And then the next thing we're going to do is we're also going to change our intervals, because when we plug the numbers into the new integral, and once we substitute these values in, these intervals are going to change. So that means that if x is equal to this value here, 1 over root 2, what is t going to be? Well, t is going to be equal to 1 plus 2 times 1 over root 2 squared. Okay, 1 over root 2 squared, and that gives us 1 plus 2 over 2, which is just equal to 1 plus 1, which is just 2. Okay, so that's our first interval here. And then if t, if x is equal to 0, if x is equal to 0, then we know that t is going to be equal to 1 plus 2 times 0 squared, which is just going to be equal to, this cancels to 0, 1. So that's our next interval. So that means when we when we substitute t and dt into our integral, the intervals are not going to be 0 to 1 over root 2, it's going to be 1 to 2. So let's go ahead and do that. So we're being asked to integrate this. Okay, we're being asked to integrate from 0 to 1 over root 2 of x times 1 plus 2x squared to the power of 7 dx, which is going to give us this right here. If we substitute our interval in, we have 1 to 2 of x. Actually, I'm going to get rid of these intervals for now. We go x times t to the power 7 times dx. All right, and as we can see here, we have t, we can rearrange it like this, times x dx. Now, what does x dx equal? Okay, what is x dx? Well, if you look up here, we can rearrange to get x dx. So if we rearrange this, if we divide both sides by 4 and bring this 4 down here, and then bring this dx up here, we would have this. We'd have this right here. We'd have t over 4 is equal to x dx. So we just perform a little bit of algebra there, and we get this expression. So now we can substitute this, this dt by 4, which you can also write this way as well. It's the same thing, 1 over 4 dt. Okay, we can substitute this back into here. We can substitute that for x dx. And so we'll do that. And so that will give us t to the power of 7 times 1 over 4 dt. And then we just simply bring out the 1 over 4. So you get 1 over 4 with our integral sign here, and I'm actually going to put in the integral or the intervals now. So from 1 to 2 of t to the power of 7 dt. So now that we've done this manipulation, as you can see, we have a much easier integral to solve now. Okay, because you see we've converted this expression here to just this. This is much easier to look at. So when we go ahead and perform that integration using our reverse power rule, we get 1 over 4 times, so we're going to raise this exponent, okay, so times t to the power of 8, okay, we're going to increase the exponent divided by 8 on the interval from 1 to 2. And then we go ahead and manipulate that more, simplifying it. You get this right here. We get t to the power of 8 over 32 from the integral of 1, or the interval of 1 to 2. And that will give us this right here, 2 to the power of 8 when we put in our numbers over 32 minus 1 to the power of 8 over 32. Punching that into your calculator will give you a number that's approximately 7.97. And that is the answer to this definite integral.